Today, we're going to talk about one of the lesser-known but fascinating methods scientists use to determine the age of ancient biological remains: amino acid racemization dating. Throughout this video, we'll explore how this process works, what types of materials it can date, its limitations, and how reliable it is compared to other more popular dating methods. Let's start with a basic question. What is racemization? Most living organisms have amino acids in their proteins, and these amino acids come in two forms or configurations. One called L, left-handed, which is what we find in living beings, and another called D, right-handed, which is not used in living organisms. When an organism dies, the amino acids in its proteins slowly begin to change from the L form to the D form in a process known as racemization. This change happens gradually and at a rate that depends on several environmental factors, such as the temperature, humidity, and pH of the environment where the remains are found. The idea behind this method is that by measuring the ratio of L to D amino acids in a sample, we can estimate how long it has been since the organism died. For example, if we find that a large proportion of the amino acids in a bone or mollusk shell sample have changed from L to D, we can infer that the sample is considerably old. One of the most common examples where this method is used is to date marine or terrestrial shells. These contain an amino acid called aspartate that racemizes at a fairly predictable rate. Let's imagine we are studying a shell found at an archaeological site. First, a small portion of the material is extracted and dissolved in a solution to separate the amino acids. Then, laboratory equipment is used to measure the ratio of L to D. Depending on the amount of D amino acids present, scientists can estimate how many thousands or hundreds of thousands of years have passed since the mollusk died. However, not everything is so simple. The accuracy of the amino acid racemization method depends on several factors that can influence the rate at which racemization occurs. The first and most important is temperature. In warmer climates, amino acids racemize faster. This means that a shell or bone buried in a desert could appear much older than it really is, if the temperature at which it was preserved is not considered. On the other hand, in colder climates, racemization occurs more slowly. Another crucial factor is the chemical composition of the soil or environment where the fossil is found. The humidity, acidity, and salinity of the soil also affect the process, which can alter the measurements. Because of this, the racemization method is more reliable when combined with other dating techniques such as radiocarbon dating or thermoluminescence. For example, if we find a shell at an archaeological site and racemization dating suggests it is 20,000 years old, but radiocarbon analysis gives us an age of 15,000 years, we could conclude that something in the environment, such as a high temperature, has accelerated racemization, making it appear older than it really is. Due to these variations, amino acid racemization is a useful method for certain applications, especially when dealing with remains that are too old to be dated by radiocarbon dating, which has a limit of about 50,000 years. Racemization, on the other hand, can help date fossils up to several 100,000 years old. A practical example of its application is in the study of fossils on remote islands, where the remains have been isolated in stable climatic conditions for long periods. Paleontologists can use racemization to establish relative chronologies in these contexts. In short, amino acid racemization dating is a valuable method, but it is necessary to use it with caution. The reliability of the method depends largely on understanding and controlling environmental factors, such as temperature and soil composition. For this reason, in many cases, it is used as a complementary tool to other more established dating methods. So the next time you hear about ancient remains found in excavations or fossils that seem too old for carbon-14 dating, remember that amino acid racemization can be a key piece in helping us decipher the history of life on Earth. However, like any scientific tool, it is essential to understand its limitations to interpret it correctly. Thank you for joining us on this exploration of the amino acid racemization dating method. Don't forget to subscribe for more content on science and archaeology. See you in the next video.